Today I will show you some experiments with gas discharges, and we will start with some nice stuff. I think let's start with argon and mercury, for example. I start the oscillator and you see, okay, it comes, you see the spectrum of the mercury, and you see this is far away from it, so there's much power. I think there are 40 watts at this moment, and if I increase the absorbed power into the plasma, you see the gas is starting to get in another mode. And this is, if we go back, this is the so-called charge-coupled mode, and we are going into the inductance mode, which absorbs much more power. You see at this moment there are approximately 80 watts are inside, and so this is it's really much power inside. It's getting very hot, and but you see it's easy to change the mode, and it's really nice. So, and you don't need to heat it up. It's just it's nice material. So I have my favorite material is neon and mercury, for example. And if you see, I come here, so you see the spectrum of the mercury, but at the edges you see the spectrum of the neon. And if I go more into the coil, you see the absorbed power is getting more, and then you see also the inductance mode is started, and it's really intense. You see much power is coupled into. And if I go more inside, you see there is much, only the mercury is remaining because of the increasing pressure inside of this tube. And you see it's really energy absorbing. For comparison, I have also pure gases, but I have helium with mercury. This you cannot start into this other mode, into the inductance coupled mode. You have a little bit problems to have enough energy. Pure helium is also easy to start. You see. Then I have argon. Then I have also neon. It's nice. So then we have another materials here. This is also with mercury, but it don't get into the mode, in the high absorbing mode. So I will show you some additional gases. I have also here prepared special material, and I will show you how it works. Now I start the oscillator, and you see, okay, the buffer gas is starting, but it's not entering. Okay, now it's entering into the mode, in the inductance mode, and then it heats up from itself. You don't need any heating, and you see the color is changing more and more. And this shows you that the pressure from the metal itself is increasing and takes control over the discharge inside. You see it's absorbing more and more energy, and it's far away from the coil itself, so that's really the inductance mode. And so I need this glass holder, so not to burn my fingers. So this is one special material. I have done this also with potassium, and to ignite it, it's also very easy without any heating, and it takes some time to heat up and to get into the spectral mode. But it's really easy to do that. you see the absorbed power is also increasing, and it's getting very bright. So for potassium, it's really a very interesting material. And you see, okay, it's glowing here. You cannot imagine how bright this is. It cannot be shown by the camera. And then I have other materials also. We have here krypton, and krypton is started, and it's 5e minus 3 millibar, and you see it enters sometimes. It's on the lower border for ignition, and we have krypton also with higher pressure. So it's more easy to get into this mode. And then you see krypton itself is also starting without any metal inside. It's starting into the inductance mode. It's a very easy to get this mode. I have this also done with xenon, and xenon ignites, but the absorbed power at this moment is so much that I have to restart the oscillator. And the process to get into this mode is not so easy. You have to add additional power, but then I can go far away from the coil, and also hold the ignition and the H mode, and the absorbed power of this small amount of gas is huge. There are approximately 90 watts inside. Over the complete distributed over the complete discharge, and so in some seconds I cannot hold this anymore because it's hot. It's very hot, and so this is. So now the pressure, I think it's too high to enter this mode. This is a quite complex process to get into this mode. So, oh, it's very hot. I also have krypton here also with a higher pressure. And you see, it's very easy to get into and hold this mode, but you have to be more inside of the discharge area, and but you cannot do anything wrong if you're in a special area. Then it starts for sure. And the power absorbed is really big. This is also the small. So this is also a plasma lamp. It's done with mercury, a smaller version. And you see there is the E field is working on it. So this is pure mercury. There is only rubidium inside. It's only the pressure, and it's processed in a special way. This tube, and you see it started also the discharge. But at this moment you can only enter into the pure spectral mode, which is it is made for. And yeah, but it's pure. It's there's no buffer gas inside. So I try to show you something about the states inside of the plasma with increasing pressure. I've investigated this phenomenon since several years, and yeah, it's a quite complex behavior. So I start the oscillator. This is a lamp which is made of buffer gas and mercury with a special pressure. So it ignites, and you see, okay, it's entering into the C field mode. but I have also to apply some heat to it, and you see the discharge is moving a little bit, and you also see some effects inside of the plasma, and you also see how the discharge starts to move. And at the end you have pure spectral light from the mercury itself, but it's not entered into the H mode, which is a very complex transition at this moment. So this is too much pressure, so you see it's getting off. And if I cool it a little bit, it's starting again. Then you see some movements inside of the plasma. Also, if I shift it, there is something happening inside of the plasma. There are some standing waves inside. So this is a well investigated phenomenon which researchers of around the whole world are looking for. And you see there are some structures inside this plasma. This is it's also a very interesting phenomenon. And you see also these structures are moving around if I moving the lamp itself.